So last time we went through and made like a package header scraper. I took basically most of that code and went ahead and just moved it over. I've done a little bit of pre-work. So tonight, what I was going to do is do some generated code. And there's just a lot to do, so I wanted to do a little bit of pre-work for you. So I'm going to walk you through where we are from last time. No real change here. We basically just have a structs file, and then we say for every file in the path, go get the data of the file, parse it, and this is literally no change from last time. I wrote a little utility to kind of look at what the ST looks like. We'll get to that in a minute. Once we have the ST, we want to go ahead and turn it into our structs that we want, and then we want to write out some member definitions. So we'll next look at the structs Odin file, and I just made just a simple little file. So this guy, I attached a custom attribute called meta, set its group, and his group name is meta, which whatever. So then we have the struct. I've put just some random stuff on here. We're not really probably going to use most or even any of it. I just wanted to kind of showcase what you can see in the ASTs. And then, all right, from there, this comment down below is from the printer. We'll come back to the comment. I just want to show the printer real quick. So from the printer, we are, out of the AST, you're given a visitor, basically. And so I wrote a print tree procedure that you can take in the root node out of your parse tree. You set up a visitor for it, right? And the visitor has two fields. It's basically data and visit. So data, you could put some custom data here, but note that it's not, like, for example, the data is not something iterative. Like, for example, one of the things I wanted to do was I wanted to have it indent. So you can kind of see the depth viewer, and that doesn't quite work the way that the visitor is set up, so be aware of that. So this is like, if you want to pass data in, that's good, but otherwise you can't really use data, right? So it's just a carrier, really. But otherwise you have the visit function or procedure, and that's this guy that I wrote here. And so all it does is say, you know, if it's not a node, throw it away. I don't know why I put that new line there, but I did. And then it goes through all the various types. I did not go to great efforts on every type, right? So if it's a type that I didn't deal with, I just had it print out the node. So this is an actual package, and it'll spit out something nasty, but that's okay, because then you can kind of see what it is. Things I did deal with, so for example, here's a comment group. So I open up usually with what the type is, and then we'll parenthesis. Let's say for every comment in the group, go ahead and print that comment out and then close it up with the new line. You know, here's an identifier, right? Same thing. I grab the name, something useful that you could look at, and what the, or that's the new line again. So we just dump this guy out. So that's really this thing. There are a few that I was trying to get clever with, and pointers are a great example. So how many pointers in a row do you have? And this was like a little helper to try to figure that out. It, again, because you don't have a great deal of control on the way the walks the tree, this gets called again, even though, like, I'd prefer if you had a pointer instead of a pointer instead of a pointer, I could rather it called once and say, hey, there's 3 pointers. But at least you can kind of see that from the outset. So if the interior type is not another pointer, it'll then go grab the name. Then we do, yeah, so got multi-pointers, arrays, things like that. So anyway, that's just it. I mean, it's just a giant switch statement that prints out stuff, right? Some of these things are, they didn't know what to do with it, so it's got goofy names, but it's still, like, again, it's a diagnostic tool, not a production tool. So there's the walk call that actually fires this thing off and has it walk the tree. And that's sitting, sorry, giant mountain of code here. So that's sitting after the initialized visitor, right? So there's the visitor, call it, walk the tree. Again, so there's our little helper guy that he's just walking down, looking at how many pointers are, you know, chained together. And then here's another one that looks at what kind of an array is it, right? Is it a fixed array? Is it a slice? Is it a multi-pointer or a dynamic array? Then we can get some field type info. Again, these are kind of utilities, so I wouldn't claim production there. There are a pair of types that I put with this, and they're just handy, so I don't know. I don't know if they're that good. I feel like this should be broken into a union or something, but I didn't take the time to do that. So the data kind is just, is it a bool, is it an int, is it another struct or something? What type of array is it, right? And that's like, it's not an array, or it's one of these guys. If it's a fixed array, then how many elements does it hold? Does it have a bunch of pointers? And so this guy, right, so it's like a double pointer, so he'd have a depth of 2. This one would be on the array. This is where it gets tricky. The array can have 3, but the interior type could have 1, right? And this was trying to kind of flatten it all on something that's a little bit nested in definition, so might would want to work on this some, but it's good enough for now. So that's, is that everything? I think that's everything. I put together this, and this is, I think I just snagged it out of another project I did. So, what's the name of your field? What's that data type? What field is it in the group? Does it have a tag? And what's its offset in the struct? Then the struct is, and this is our custom field for our group, so this should be like meta, for example. What's the name, and then what are the fields it holds? So then we go into the extract structs, right? So we take in a file, and we're going to spit back out structs. We go through each of the declarations, and this is mostly, like, this is what we took out of the code from last night. So if it's a value declaration, right, so we're going to test this this union declaration. So if it is, basically if it isn't, that's going to be things like imports. We're going to skip them, right? We don't have any interest in imports. If it has no attributes, we don't care, because we only want, as far as the generated code goes, we only want things that have attributes, right? So we don't know if it's the attribute we want yet, but we do know it at least has attributes. So we're just winnowing down. Then we're going to go through and test that. So this is just a little helper that goes and fishes out what is that, the name of that attribute, and did it have the correct attribute, right? Because this could be, where did you go? This guy. So this could have, I don't know, private, right? Private. So now he's got 2 attributes. And so we want to make sure that at least one of those attributes was our meta attribute. It's that guy. Then after that, we're going to make our struct. We'll go ahead tonight, we'll fill it in. We stick it on our list of structs, then we return it. In the attributes, we'll fish through that. And then the last helper we have here is to write out the generated file. So we want to get rid of the old file. We want to open a new one. Now, if you're going to make something more robust, you probably want to make sure that the folder structure is in place, right? So I've got manually added the gen file folder. This would probably crash because it doesn't exist, but whatever, demo code, I guess. So we're going to open it. I am going to make a string builder. Yeah, and we're going to get rid of it when we're done. Then we're going to go ahead and write into the builder, what package are we? And actually, I believe that's going to be, pretty sure he needs a new line. Let's go ahead and actually test this, because I'm having a moment here. So we're going to run it real quick. Yes, we do need the new lines. Okay, perfect. So we're already producing code, which is pretty cool, right? We didn't really make anything useful, but there's that. So on the struct, I went ahead and ran that print tree, and then I've manually tabbed this out again. You can't use the walker to do the tabbing, but now we can see what's inside, right? This makes it a world easier when you're trying to work with AST, right? They're really opaque, you know, it's because it's a bunch of like nested unions of Russian dolls almost, and you don't know which path to take to go get what you're interested in. And so that little printer spits out this thing, which gives us enough information that we should be able to go chase down what fields we need. So I'm thinking we're going to start with the attribute. So we're going to bring this little guy back over here. And I guess we'll just stick it right there for now. And so what we want to do is we're going to say, okay, so I've already set up the loop of for every attribute in the attributes, we want to say we want the field values. We're going to say fv and okay is adder dot. We want a field value, and he's going on memory here, but I think he's in this guy. Dot derive. Oh gosh. See, I say this is easier, but there's still a little bit of like sometimes what I'll do is I'll just print out elements, right? And then you go. In fact, I'm going to show that real quick just because he's ready upset because he's not used. Okay, so let's just do this real quick. So we're going to just copy that out. We're going to do format dot print line of that thing, right? So I know there's one, so this will just save us a little bit of heartache. Oh, very important note. When you add custom attributes, you actually need a compiler flag of ignore unknown attributes. So if we run without it, I did add a PR for this thing yesterday, I think, so maybe by the time you do this, it'll be in, but it's going to cry saying it doesn't know how to deal with this custom attribute, right? So make sure you have that guy on. So we print this out, and we're going to get this nasty thing, right? And when I'm first building something up, I'll usually take it and dump it over here. And it's a little bit tedious, but I've not yet found a better way. If someone knows one, I'm super interested because this frankly kind of sucks. Right? So we're just looking what's in this thing, right? So we know this is an expression and expressions have derived, right? So we know whatever we're looking for is there. So we would come back to this thing. Is that, where's my print? Here it is. So we know it's an expression. We know it's in derived. So we're going to go ahead and do the derived, right? So we'll do that again. And now, in fact, you're starting to see there's a field, right? So there's new things that have showed up because we're now in a field value. So that's really, I just want to show that because that's probably the hardest thing about figuring this out is like sometimes you just kind of tediously poke around till you know what you're looking for. So now we got this guy. And so then what we're going to do is we want the this is the adder name, right? And so that's going to be fv dot derived dot ident, and we probably want to okay. And in here, in fact, we're just going to let that fail. Oh, he's not going to let me. I have to okay. We'll say assert okay. Right, we want to make sure that that's that guy. So if adder name is not meta, right, this is what we care about, then we want to continue. So, oops, eighth column is not meta. Why don't, oh, very useful if we go get the name. So now we're on this guy. We're good. So then we want to get the comp lit. And so That was the first piece. We're going to go to the next piece, right? So now we've basically cycled through any attribute that isn't this guy. Oh, and one important thing is we know now that it has meta, right? So that's one of our return values. It definitely does have a meta field. So then we said that this was a comp literal. So we'll say cmp lit and COK. COK is the field value dot. I'm confused now, actually. It's the field value, or is it the adder? I think it's on the adder. Yeah. Okay, so then that's active dot. I think this is the derive. Or is that the I think it's the drive. Let's try that. And we don't know, so let's, well, we could try it this way. We can always just have it blow up, right? So we'll just say assert COK, and what's inside this thing? So then we have another field value, and then we'll get, okay, so then we have another field value. Don't need the other one anymore, I don't think, so we're just going to reuse them. So he's going to be the comp literal dot. Is he also elements 0 dot derive? Now in this case, so right here you're going to want to loop. You don't want to have, right? We'll say technically should iterate through FEs here, and really should here too, right? In fact, we're going to say technically should iterate through FEs, just like straight up. So if the yeah, you should, but I'm not going to. So then we want another ident, and we're going to just assert OK. Cannot assign value. Oh, wait. No. I'm totally, I gotta get the field value first. Field value. Right, and so then now we can get the ident. So in fact, we're gonna just steal this one. Yank him, right? So we'll just take this thing again and drop him down there. Now it's just a reassignment, and it's actually on FE, so we're good. And so then we've gone from here to here. Now we're here. So the ident.name, actually, I think that might not be there. I think that might be like that. So then we're just going to assert that ident.name equals group, right? And then we want to go FE dot. So we did derived there. Oh, actually, am I doing that wrong? This might explode. So we'll see. FE dot value dot derived dot literal group and okay. So then assert okay. We derived not. Oh wait no. So that's group grp lit Okay. So then group equals grp lit dot. Did I goof it? I think I goofed it. Yeah. Okay, but let's just see where we are because we're probably gonna explode. So let's go ahead and explode. So we blew up at 78, and yes, I think what we're doing here is this wants to be blew up at 70. Oh, we blew up on this one. Sorry. Okay, so then I think it's the value dot derive. Maybe. Blew up on 78 still. All right, we're gonna print them out. So print line fb dot value, and you're just gonna see what you look like. You're an expression. Derived. Now you're a complet. I'm going the wrong way. So this is headed towards our buddy the name, right? So that the value dot derives, that's this guy. Wait a minute. The field value. I gotta back up, man. We're all messed up. Let's do the field derived. Right, there we go. Okay, we're just all screwed up. So we're the field dot derived, right? And that in theory should fix that guy. So now we're gonna come down here, and it's still the field value dot value dot derived, I think. So let's see how we explode now. And we blew up at 84, right? So then we're gonna be the same as this one. So it's the field. So this one's to be the field derived. Now we should whoop a little further down. Oh, we made it through. All right. So now the group literal. Let's just print that guy because I'm not real sure about him either. Print line grp lit, and he is a basic literal. Is it just what? How do you grab his dot text? So we can just do group lit dot text. No. Dot text. Very upset. Basic literal has no field text. So we need to grab that off of not seeing it yet. So we got a node, and that's open 3 2 3 2 1 0, right? So that's all that crap that can come down. This guy. So it's token text. There it is. Okay. So it's token Next. Make sure we got it. All right. And what we want to do is we don't actually want the whole thing. We're going to take from one, and then I think we're going to slice it again. Maybe, oops. Maybe we'll do this guy, like -1, right? Because I don't want the quotes. There we go, good. So now we can just say group equals this thing, and we're done. So then we have grabbed the attributes out, right? And you probably want to like not hardwire these and not use zeros, but that's what we've got time for. So I think attributes are done. So we'll just nix that. We're going to move this thing up there. Just for grins, let's just do a print line on group and as meta, right? We should see meta true. And we see meta true, perfect. Okay, so that is that guy. Toss that out, and we're going to come back to our little helper here. Let's fix, did we just say that was? Whatever. So now we're on to this guy, right? So take the rest of that stuff and bring it over. So we are going through the decals, and we've discarded anything that doesn't have that attribute. And so at this point, in fact, I mean, technically we've not actually turned this into a struct, right? So we're not here yet. Oops. Not at the value decal. So we're not, we're up here. But because in this case we know for sure that it's a struct, I think we're just going to say for now, right? And then I wouldn't do this if you want like unions and enums and stuff, but just say we're only tagging structs, ergo matter flag of prunes everything else out. So from there, we're going to say the struct, we're in extract structs, right? Yeah. So the struct is going to be the decal dot derived dot struct type, and we're just hard declaring it, right? So that's going to explode if you tag something else. So then, in fact, we'll just make it super explicit. So we'll say assert SOK only structs can be meta act, right? And just to prove that out, let's come over here, and we'll just say a union is actually a union, not a struct, and we'll just do like int bool, right? Something simple. We'll just take you, we'll stick you up there, and we should explode, right? So now we got this. Only structs can be meta tagged, just like we wanted. Perfect. Get rid of that. And back to you. So we now know that we're a struct. The struct, right? So then we've gone into the decal, and I think we need to fish. In fact, again, this is where I really wish I could do the idents better. So that needed to come flat, because I think these are both sitting under the decal. So we'll first need to get the name, and so the name is going to be the decal dot, or is it? Maybe it's under the struct. The struct dot. Oh dear, I've forgotten where the ident lives. So where the hell does the ident live? Let's go back to the full printout. In fact, you know what we can do? We're gonna just take a second here, and we're gonna do, where's my helper? This guy, right? So what we want to ask it is, what the heck is in the struct? So we'll run that, and we'll explode. Only structs can be meta tagged. Only structs are meta tagged. And are you gonna cry? Redeclaration. Oh, son of a gun! Look at that. It really helps if you're looking at the right thing. So val dot, and then it's values, and we're the first value, and we made the derived of that. Some beach, man, some beach. So the name is not the primogen. Now names, and I don't know how you could have two, but I'm assuming you can. Don't know. So then let's just print that guy out, right? Print line of the name. It's this guy, and that should be good. So we're going to print the struct, right? This should all theoretically not explode. Right. So we got to actually grab the name out of the name, right? So this is name stir name node, I guess, and the name is equal to name node dot name, right? It's assigned equal to. So we're good there. So now we grabbed the struct. So we got this guy, and so now we want to iterate through the fields on the struct. And I think this is where I'd written a helper function for this. Well, let's see here. So now we can say inside this thing, we can actually say name equals, in fact, I'll just do name node dot name, right? No need to rehash that. Then devs extract adders. Let's go to the printer and collapse everything. Extract field type. Okay. So I need to actually probably get the field first. So we'll come back here. And I guess we're doing the to-do here, so I'm not worried about that. So this guy, now what we want to do is the struct dot fields. So for field in the struct dot fields, don't be mad. Cannot iterate type of field list. Field list is the struct dot fields. I mean, not. Do I we need to actually just do list. That'd be kind of, oh, it is too. Okay. So now, what are we going to do? We're going to do F, let's see, field dot, and I think this is the point we're going to want to go ahead and set up these guys. So what do we got here? We got, where is my little struct definition? It is a slice. So we know the length of the list, so we're going to do, in fact, yeah. So we'll do I right there. And then we're going to say fields equals make an array or slice of fields, and it's going to be len the struct dot fields dot list. Right, now that means you need to live up here, and oh, you don't like it. Not a con. So put it there. No, we won't put it there. I have to put the struct first. There it says. Alright, so my current field, and then do that get field info, get at, no. Field, extract field type from field, and dt. And dt. So dt is a data type, right? No? You don't like it? Cannot assign field of type field to, it's actually under the type info, right? And if I could read, it's field type. Hey, look at that. So now we've got a bool, it's not an array, right? We've got a struct, and it's a double pointer. We got F32, and it's a slice. Why that's -1, I'm not real sure. So what I had changed was this guy. So my struct is 1 deep, right? That's that one. Before it was 2 deep. We're just gonna leave that there. This should really be 1. Takes the field type proc. Yeah, that's the bug there, but we'll deal with that in a minute. So this guy is that, and then we can now say field, oops, current dot field dot type equals dt, and then dot name equals field dot, I guess these names 0 dot 5 dot ident. This thing, right, it's going to be id dot name. So then we want, does it have tag equals field dot tag dot text, right? If it has any. And then the index, does that come? That's actually just I. Know anything about it? Byte offset. I don't remember how I was getting this one. Field dot. We're gonna just strip that one because I probably was doing something else. Not even something very clear. Name type index tag. I think we got everything. So then we want to do current.group equals group, right? And anything else we're missing? We got that, we got that, we got that, we got all that. I think we're good. So now I think we're done with the AST. So just for S in struct format dot S. And so, well, we only have one struct, so that makes sense. Meta struct there's field A, which is a bool. I wish this thing could pretty print. I got that. So now I'm gonna come down here, and we just want to do. Let's do right string, and this be, and I want meta colon open curve. And this guy, and probably I'll just make that stuff. Okay. And that should produce an enum. In fact, we'll just yoink that. Let's look at that first. Right, and we now have an enum. So just to make life slightly more interesting, just take you, do that, and F32. Blah, blah, blah. Then we come to I think what to do next with it. So run it with that, I should get this should probably get a double new one. Yep, and registering everybody in. So then from there we'll do this whole thing. And he's going to be a map. Right, so it's like an enumerated map. And let's say that guy. What's the other type going to be? Try to decide what to do with that. I mean, you could do like byte offsets or something. It's in our. Yeah, we're just gonna do this. This is silly, but whatever. So that name equals, and it's just going to be and the tabs. Missing the tabs. Yep. Okay. So we need tab. Here, tab. Dot a struct is 3. A constant. Okay. Right, back to this guy. This guy wants to be equals. I can't tell if he was happy with me or not. And some spaces. Alright, so do that. Come back here. And not the most useful metaprogram, but definitely a metaprogram nonetheless. And what we can do now is we can come up to main, right? We'll just say if we do return, not interested in that one, and say format dot print f. Should just do kvn. We call it metamap. Metamap. Oh. So that is dot gen slash so again, this is probably the least interesting metaprogram in the world, but that's not the point. This is how to build the metaprogram, not necessarily how to make one that's useful. So there you go. Boom. We now have a custom metaprogram.